In March 1944, a P-47D Thunderbolt limped back from a bombing mission over Germany, its massive radial engine spewing smoke after taking flak damage. The pilot, attempting to reach Allied lines, misjudged his fuel and force-landed in a field near Frankfurt within 10 days. The heaviest fighter ever built, a 7-ton monster that German pilots mockingly called Jug like the Americans, but secretly feared, was sitting at Rechlin Test Facility, where Luftwaffe pilots would discover that American engineers had built a fighter that could dive at 500 miles per hour without disintegrating, that could absorb damage that would destroy any German aircraft, and that represented a design philosophy so fundamentally different it challenged every German assumption about what made a fighter superior. This is the story of how flight testing revealed that mass and power could defeat elegance and agility, how brute structure trumped lightweight, and how the reports written by honest men traveled through a bureaucracy that could not accept what the data proved. Subscribe now if you want the buried stories of World War II's technological battles, the engineering intelligence that shaped air combat, the test flights that revealed uncomfortable truths, and the human cost of ignoring data. We're going deeper than any other channel. Hit that button. March 9th, 1944, Rechlin-Leers Airfield, Mecklenburg, Germany. The morning is cold, winter still gripping northern Germany with below-freezing temperatures. The sky a solid mass of gray clouds, wind cutting across the field carrying the smell of coal smoke and aviation fuel. Oberstleutnant Hans-Werner Lurch stands on the frozen concrete apron, hands shoved deep in the pockets of his fleece-lined leather jacket, studying the aircraft before him with an expression that mixes disbelief and something darker apprehension, perhaps, or the recognition that this evaluation will confirm fears he has been nursing for months. The Republic P-47D Thunderbolt, serial number 4225512, sits awkwardly on German soil, its massive fuselage and bulbous radial engine covered by a thin layer of frost, the four-bladed propeller motionless, the 8.50 caliber machine guns in the wings silent. The aircraft force-landed 6 days ago near Frankfurt. Its pilot, First Lieutenant Michael Davidson, 25 years old, from Massachusetts, captured after attempting to set his aircraft on fire. The fire did not catch properly. The aircraft survived with moderate damage. German recovery crews extinguished the smoldering remains, loaded the aircraft onto rail flat cars, transported it to Rechlin, and now it waits, an American intruder on German territory, ready to reveal its secrets. Lurch is 31 years old, one of the Luftwaffe's most experienced test pilots with over 2,100 hours in more than 75 different aircraft types. He has flown captured Allied fighters before, Spitfires, Mustangs, P-38 Lightnings, even an Airacobra for about 40 minutes before the engine failed catastrophically. Each evaluation has been educational and disturbing in equal measure. Each aircraft has revealed capabilities that challenge German assumptions about fighter design. But the P-47 is different in ways Lurch does not yet fully understand. Intelligence reports describe it as heavy, unmaneuverable, more suited as a fighter bomber than an air superiority fighter. But German combat pilots who have encountered it over Germany tell different stories. They speak of an aircraft that cannot be caught in a dive, that absorbs cannon damage that would destroy a Bf-109, that keeps fighting with engines leaking oil and fuselages riddled with holes. They speak with fear of the P-47's firepower, 8.50 caliber machine guns that can turn an aircraft into wreckage in a 2-second burst. And they speak, almost with reluctant admiration, of the P-47's refusal to die, of American pilots flying damaged aircraft back to England when any German fighter would have fallen from the sky. Lurch is here to understand this aircraft, to measure its capabilities, to discover whether combat reports are exaggerating or understating the threat. He suspects he will find they are understating it. Behind Lurch, 3 other pilots wait in the March cold, wearing heavy leather flight jackets, fleece-lined boots, thick gloves. Major Heinz Bauer, 24 years old, one of the Luftwaffe's highest-scoring aces with 197 confirmed victories. A combat veteran who has fought on every front. Hauptmann Wolfgang Spate, 26 years old, a specialist in high-altitude testing, later to become one of the first Me-163 Comet rocket fighter pilots. And Lieutenant Rudolf Opitz, 23 years old, an engineer pilot from Messerschmitt, brought to Rechlin specifically to evaluate captured enemy aircraft and provide technical analysis. Each man has his assignment. Lurch will conduct initial flight evaluation, assessing basic handling qualities and general performance. Bauer will conduct tactical evaluation, determining combat advantages or disadvantages against German fighters. Spate will conduct high-speed dive testing, pushing the P-47 to its absolute structural limits. Opitz will conduct instrumented testing with recording equipment, documenting precise performance data. Together, they will answer the question, is the P-47 Thunderbolt as dangerous as combat reports suggest? Or are German pilots making excuses for losses that should be attributed to poor tactics or inadequate training? The P-47 has been made airworthy over 6 days of intensive work by Recklin's ground crews, supervised by civilian engineers from Focke-Wulf and BMW, who have some experience with American radial engines. The damage from the forced landing was moderate: bent propeller, collapsed main landing gear on one side, ruptured hydraulic lines, dented wing panels. German mechanics fabricated a new propeller using measurements from the damaged one, though the blade profiles are approximate, not exact. The landing gear was repaired using parts from another captured P-47, destroyed in testing the previous year. The hydraulic system required extensive work, the German technicians struggling to understand the complexity: hydraulically operated flaps, hydraulic brakes, hydraulically operated cowl flaps, all controlled through a sophisticated system that is far more complex than German fighters. The electrical system was another challenge, with the P-47 featuring a massive engine-driven generator, a complex bus system distributing power, and more electrical equipment than any German single-engine fighter. But the German technicians are skilled, experienced, determined. They make it work. The most significant challenge was the engine. The Pratt & Whitney R2800 Double Wasp is an 80-inch cylinder, air-cooled radial, fundamentally different from the liquid-cooled inline engines that dominate German fighter design. The radial is massive, weighing 2,360 pounds, not counting propeller and accessories, producing 2,000 horsepower at takeoff, 2,300 horsepower at war emergency power with water injection. German engines: the Daimler-Benz DB605 and the BF109. The BMW 801 radial and the FW190 produce 1,475 horsepower and 1,700 horsepower, respectively. The American engine has 35% more power than the best German fighter engine, but power comes with mass. The R2800 and the captured P-47 sustained minor damage from the flak fire that forced the landing: 2 cracked cylinders, severed oil lines, superficial cooling damage. German engineers replaced the damaged cylinders with units machined at BMW, copied from measurements of the originals. The oil lines were fabricated from available tubing. The turbocharger, mounted in the rear fuselage and connected to the engine through extensive ducting, was checked and found functional. The repairs are adequate but imperfect. The engine will run, will produce power, but whether it will achieve full-rated performance is uncertain. The armament: 8 Browning M2, 50 caliber machine guns mounted in the wings, 4 per wing, was test-fired yesterday. All 8 weapons functioned perfectly. The firepower is devastating, heavier than any German fighter, equivalent to a medium bomber's defensive armament. Lurch walked slowly around the P-47, examining every detail with the trained eye of an engineer and combat pilot. The aircraft is enormous, far larger than any German single-engine fighter. The wingspan is 40 feet, 9 feet narrower than a Bf-109, but the fuselage is massively thicker. The length is 36 feet, comparable to the Bf-109, but the weight is shocking. Empty weight is 10,000 pounds, nearly double the Bf-109's empty weight of 5,900 pounds. Fully loaded with fuel, ammunition, and pilot. The P-47D weighs 14,500 pounds, over 7 tons, heavier than many light bombers. Everything about the aircraft suggests it should be slow, clumsy, a target rather than a threat. Yet combat reports describe it as fast at top speed, lethal in dives, nearly indestructible. How? Lurch needs to understand how. The radial engine dominates the forward view, an enormous oil cooler hanging below it, making the aircraft look even more bulky. The fuselage is thick, barrel-shaped, optimized to house the large engine and turbocharger system. The wings are elliptical, relatively thin, built with flush riveting that creates a smooth skin. The tail is large, upright, providing stability for the heavy fuselage. The configuration is conventional, but everything is scaled up, larger, heavier, more robust than any German fighter. The cockpit sits high, providing excellent visibility in all directions except directly forward, where the long nose and massive engine block the forward view. Ground visibility will be poor, requiring asterns during taxi, as with all radial engine fighters. The canopy is framed but with large panels comparable to late production German fighters. The instrument panel, visible through the canopy, appears logically organized with large readable gauges. Lurch climbs the side-mounted ladder to the cockpit entry on the left side. Entry is easy, the cockpit large enough to accommodate big pilots. American pilots, Lurch thinks, are larger on average than German pilots, and their equipment reflects this. Everything is scaled for comfort, not minimal efficiency. The cockpit is spacious, wider and taller than any German fighter Lurch has flown. The seat is adjustable, thickly padded, with excellent lumbar support and armor protection behind and below. The armor plate behind the seat is 1 inch thick, forged steel that would stop anything except direct cannon fire. The Bf-109 has an 8mm armor plate. The P-47 has tripled the protection. American pilots, Lurch recognizes, are designed to survive. The instrument panel is comprehensive, airspeed indicator, Altimeter, rate of climb, turn and bank, artificial horizon, directional gyro, compass, all standard instruments but higher quality than German equivalents. With clearer markings, smoother movements, better illumination. The engine instruments are extensive: manifold pressure, RPM, fuel pressure, oil temperature, cylinder head temperature, exhaust gas temperature. Monitoring the R2800 requires constant attention. The throttle quadrant features multiple controls: throttle, propeller pitch, mixture, a small switch marked water injection for emergency power, cowl flap controls. The complexity is intimidating. German fighters have one throttle, one propeller control, most other functions automatic or semi-automatic. The P-47 gives the pilot complete control over every engine parameter. This is both advantage and disadvantage. Advantage: the pilot can optimize performance. Disadvantage: the pilot can make mistakes that damage the engine or reduce performance. A German mechanic, Unteroffizier Franz Weber, 34 years old, climbs up to provide the cockpit briefing. Weber was a civilian aircraft mechanic before the war, trained at BMW, conscripted in 1941. Assigned to Rechlin because of his technical expertise with radial engines. He has studied the P-47 for 6 days, experimenting with controls, consulting the pilot's notes captured with the aircraft, interviewing mechanics who worked on the previously captured P-47. Weber explains the startup procedure: battery on, fuel boost pump on, fuel selector to main tank, mixture rich, propeller full forward, throttle cracked open 1 inch, magnetos to both, energized starter. The procedure is similar to German radial engine aircraft but with more electrical complexity. He warns about the R2800's tremendous torque, requiring heavy right rudder on takeoff. He warns about the turbocharger. It is delicate, requires careful throttle management, can be damaged by rapid throttle changes. He warns about the water injection system, use only for emergency power. Limited to 5 minutes maximum, can damage the engine if overused. Weber's warnings are numerous, detailed, slightly frightening. This aircraft is powerful. This aircraft is complex. This aircraft demands respect. Lurch settles into the seat, adjusts the rudder pedals, tests the control stick. The P-47 uses a stick rather than a wheel, conventional for a fighter, mounted centrally with a comfortable grip. He locates the gun sight, a simple reflector sight projecting a reticle onto a combining glass. Less sophisticated than some American fighters, but adequate. He runs through the startup checklist, memorizing each step, then signals Weber he is ready. Weber climbs down, and Lurch is alone with 7 tons of American fighter aircraft. Battery switch on. The instrument panel illuminates, gauges coming to life, fuel boost pump on, the electric pump humming, fuel selector to main tank, mixture control full rich, propeller control full forward, throttle open 1 inch, magnetos to both. He presses the starter button. The R2800 cranks slowly, the massive propeller rotating through compression strokes, once, twice, 3 times. Then the engine catches with a thunderous roar that shakes the entire airframe. 18 cylinders fire in sequence, each exhaust stack ejecting flame and noise, the whole engine vibrating with barely contained power. The sound is nothing like a German engine. The Daimler-Benz DB605 sounds mechanical, precise, engineered. The R2800 sounds like industrial machinery, like a locomotive, powerful and rough and absolutely relentless. The propeller spins up, the cockpit fills with vibration and noise, and Lurch feels the aircraft come alive beneath him. He monitors the engine instruments as the R2800 warms. Oil pressure climbs to 75 psi, normal. Cylinder head temperature rises slowly toward operating range. Manifold pressure shows 30 inches. Idle power. Fuel pressure shows 15 psi from the boost pump. Everything appears normal. He tests the magnetos, switching from both to left, checking for RPM drop. Acceptable drop, 75 RPM. He switches to right magneto, similar results. Back to both. He cycles the propeller pitch control, watching the RPM change as the blade angle adjusts. The constant speed propeller responds smoothly. He tests the turbocharger wastegate, manually opening and closing it, watching manifold pressure change. The turbocharger is functioning. He tests the flight controls, moving the stick and rudder through full travel. The controls are heavy, heavier than any German fighter, requiring significant force even on the ground. The ailerons are particularly heavy. Though there is no hydraulic boost, the P-47 relies on pure mechanical advantage and pilot strength. He is ready to taxi. He releases the toe brakes and advances the throttle slightly. The P-47 begins to roll forward, heavy, ponderous, the single engine pulling with enormous torque. He compensates with differential braking and rudder, is sterning down the taxiway, looking around the massive nose. Forward visibility on the ground is terrible, worse than any German fighter, the engine completely blocking the forward view. He must constantly look left and right to see where he is going. He reaches the runway threshold, turns into the wind, runs through his pre-takeoff checks. Mixture rich. Propeller full forward, maximum RPM. Cowl flaps open for maximum cooling. Fuel selector on main tank, magnetos both. Engine instruments checked all normal. Trim set. Elevator slightly nose up, rudder far right to compensate for torque. Flaps up. The P-47 does not use flaps for normal takeoff. He takes a deep breath, grips the stick tightly with his right hand, positions his left hand on the throttle, and advances the throttle to full power. The acceleration is violent, shocking, beyond anything Lurch has experienced in a fighter. The R2800 howls, the propeller claws at the air. And despite weighing over 7 tons, the P-47 rockets down the runway like it has been launched from a catapult. The torque is tremendous, the aircraft trying to swing viciously left despite Lurch's heavy right rudder input. He feeds in more rudder, nearly full right rudder, fighting the aircraft, his left leg straining against the rudder pedal. At 60 miles per hour, the tail comes up. At 95 miles per hour, he eases back on the stick and the P-47 lifts off, climbing away from the runway with authority that seems impossible for something this heavy. There is no grace, no elegance. This is brute force, raw power, overwhelming mass through sheer mechanical violence. He retracts the landing gear, watching the wheels fold up into the wings. He reduces power to climb setting, 2,550 RPM and 42 inches of manifold pressure, and the P-47 climbs at 2,800 feet per minute. The Bf-109 G6, Germany's primary fighter, weighing half as much, climbs at 3,100 feet per minute. The P-47 is only marginally slower despite weighing twice as much. The power-to-weight ratio is nearly equal. American engineers have solved the weight problem by simply adding more power. Brutal, inelegant, effective. Lurch levels at 10,000 feet and begins basic handling tests. Turns to the left, turns to the right, steep banks at 45 degrees, then 60 degrees. The P-47 responds smoothly but very heavily. The control forces are enormous, requiring significant physical strength to move the stick. The roll rate is poor, perhaps 60 degrees per second at 250 miles per hour, far slower than a Bf-109's 100 degrees per second. The turn rate is adequate but not exceptional, the aircraft's massive weight-limiting sustained G capability. In a pure turning fight, a Bf-109 would have overwhelming advantage. But Lurch realizes immediately that American pilots would never fight that way. Why turn when you can dive? Why dogfight when you can boom and zoom? He tries a loop. The P-47 loops easily, the powerful engine maintaining energy throughout. He tries a barrel roll. The roll is slow, ponderous, taking 6 seconds for 360 degrees. The Bf-109 rolls in 2 seconds. These aerobatic maneuvers are not what the P-47 is designed for. He needs to test what it does well. Speed, dive, energy retention, structural strength. He levels at 15,000 feet and begins speed testing. He advances the throttle to military power, 52 inches of manifold pressure and 2,700 RPM. The turbocharger boosts, compressing thin air to maintain power. The P-47 accelerates, building speed with impressive authority. 300 miles per hour, 350, 380, still accelerating, 400, 420, 428. The airspeed stabilizes at 428 miles per hour at 15,000 feet. The Bf-109 G6's maximum speed at this altitude is 387 miles per hour. The P-47, despite weighing twice as much, is flying 41 miles per hour faster. How? The answer is power and aerodynamics. The R2800 is producing nearly double the horsepower of the DB605. The P-47's smooth skin, flush riveting, and careful attention to streamlining create lower drag than the weight would suggest. The result is speed that exceeds lighter fighters. Lurch maintains this speed for 5 minutes, monitoring the engine. Cylinder head temperature is 232 degrees Celsius within normal limits. Oil pressure is 70 psi, normal. The turbocharger is maintaining 52 inches of boost without strain. This is military power, sustainable indefinitely. The P-47 can cruise at speeds the Bf-109 achieves only at maximum power. He climbs to 20,000 feet and repeats the test. The P-47 reaches 432 miles per hour at military power. The Bf-109 G6 achieves 398 miles per hour at maximum power at this altitude. The performance gap is 34 miles per hour and widening with altitude. The turbocharger is maintaining power as altitude increases, while the German supercharger loses effectiveness. He climbs to 25,000 feet, the altitude where much of the air war over Germany occurs. He levels off, advances the throttle to war emergency power, 60 inches of manifold pressure, 2,700 RPM, and water injection engaged. The R2800 responds with a surge of power, the water-alcohol mixture cooling the intake charge, allowing higher boost without detonation. The P-47 accelerates 400 miles per hour, 420, 435, 440. The airspeed stabilizes at 440 miles per hour at 25,000 feet. The Bf-109G6 achieves 390 miles per hour at this altitude at maximum power. The P-47 is 50 miles per hour faster, and this performance's sustainable war emergency power can be maintained for 5 minutes, while the Bf-109's maximum power is sustainable for only 2 to 3 minutes before engine damage occurs. But Lurch knows the real test is still ahead. Combat pilots speak with awe of the P-47's dive performance. He needs to test it. He needs to know if the reports are accurate, if this massive aircraft can really dive at speeds that would tear a German fighter apart. He climbs to 30,000 feet, his highest altitude for the initial test. At 30,000 feet, the air is thin, cold, the sky above deep blue fading to black. He stabilizes, checks his harness tied secure. He rolls the P-47 inverted, a slow, heavy roll that takes 4 seconds. He pauses, inverted, looking down at the earth 30,000 feet below, then pulls the stick back, pulling through into a vertical dive. The P-47's nose drops toward the earth, the aircraft entering the dive smoothly, stabilizing in a perfect vertical descent. The airspeed begins building. 300 miles per hour, 350, 400. The dive is stable, smooth, no buffeting, no vibration. 450 miles per hour. The control forces are increasing dramatically, the stick requiring significant strength to move, but the aircraft remains perfectly controllable. 480 miles per hour. Lurch glances at the altimeter, 24,000 feet. Still diving. Still accelerating, 500 miles per hour. The indicated airspeed stabilizes at 500 miles per hour, the P-47 screaming toward the earth in a vertical dive, and the aircraft is rock solid. No flutter, no buffeting, no structural vibration. The wings are not deforming, the control surfaces are not failing. The airframe is absorbing forces that would destroy any German fighter, and it is not even straining. Lurch maintains the dive for 10 seconds, experiencing 500 miles per hour. The fastest he has ever flown, the ground rushing up with terrifying speed. At 15,000 feet, he begins the recovery, pulling back on the stick with both hands, using all his strength. The stick is immovably heavy, the control force is enormous, but it moves slowly. The elevator biting the air, the nose beginning to rise. G-forces crush him into the seat, his vision graying, then tunneling, then almost blacking out as the G-forces exceed 7. The G-suit helps, but barely. The P-47 pulls out of the dive at 8,000 feet, having lost 22,000 feet, and levels off smoothly. Lurch's vision clears. His hands are shaking. He checks the airframe visually, looking at the wings. No deformation, no damage. The P-47 just survived a 500-mile-per-hour dive without strain. The Bf-109 can dive safely to 470 miles per hour before experiencing severe buffeting, control stiffening, and risk of structural failure. The FW-190 is better, cleared to 550 miles per hour, but even it experiences significant buffeting above 500. The P-47 at 500 miles per hour is smooth, stable, controllable. This is not a marginal advantage. This is categorical superiority in the dive regime. American pilots can dive to escape or dive to attack, building speeds German pilots cannot match, pulling out at altitudes where German aircraft would disintegrate. The dive advantage compounds the speed advantage, making the P-47 nearly untouchable if flown correctly. Lurch climbs back to 25,000 feet, his mind processing what he just experienced. The P-47 has redefined what is possible in a fighter aircraft. Mass is not a disadvantage if you have enough power. Structural strength is not wasted weight if it allows you to survive maneuvers that kill enemy pilots. The Americans have built a fighter that contradicts every principle of German design philosophy, and it works. It works devastatingly well. After 2 hours of flight, Lurch returns to Rechlin. The landing is straightforward. The P-47 touching down at 100 miles per hour. The landing gear absorbing the impact without complaint. He rolls out, reduces power to idle, taxis back to the apron. He shuts down the engine, the R2800 coughing once, then falling silent. He sits in the cockpit for 2 full minutes without moving, processing what he has just experienced. The P-47 is fast as or faster than German fighters despite weighing twice as much. The P-47 dives at speeds no German fighter can match safely. The P-47 is built like a tank, with structure and armor that would allow it to survive damage that would destroy a Bf-109 instantly. The only area where German fighters retain clear advantage is turning performance, and that advantage is tactically irrelevant if American pilots refuse to turn fight. The Americans have built a fighter optimized for speed, energy, survivability. German fighters are optimized for maneuverability, efficiency, elegance. In 1944, the American approach is winning. Heinz Boer is waiting as Lurch climbs down. Boer, with his 197 victories, asks what Lurch found. Lurch looks at him and says, "I just dove this aircraft to 500 miles per hour. It was smooth, stable, controllable. Our fighters cannot do this. No fighter can do this. The Americans have built something that rewrites the rules." Burr's expression hardens. He says, "Then I need to fly it. I need to understand how to fight it." Lurch nods. "You fight it by not fighting it. This aircraft is invincible in a dive. It is faster than our fighters in level flight. It is nearly indestructible structurally. Our only advantage is turning, and American pilots are trained never to turn fight. We are in serious trouble, Heinz." Bauer climbs into the P-47 for his flight, determined to find weaknesses, certain they must exist. He will be disappointed. Burr's flight profile is tactical, testing the P-47 in combat scenarios. He discovers that the P-47's acceleration from cruise to combat speed is excellent, taking only 25 seconds to accelerate from 300 to 400 miles per hour at 20,000 feet. The Bf-109 requires 45 seconds for the same acceleration. Response time advantage. P-47. He performs mock dogfights, discovering that the P-47's heavy controls and poor roll rate are significant disadvantages in sustained turning combat. But he also discovers that the P-47 pilot would never allow sustained turning combat to develop. If the engagement becomes unfavorable, the P-47 pilot simply pushes forward on the stick and dives. The German pilot cannot follow safely. The P-47 opens range, escapes, resets. Speed provides choice. German fighters lack choice. He tests the P-47's zoom climb capability, diving to build speed, then pulling vertical. From a 450 mile/hour entry, the P-47 zooms to nearly 9,000 feet before stalling. Energy retention is extraordinary. The massive mass, once accelerated, resists deceleration. The P-47 carries energy through maneuvers that would bleed a lighter fighter dry. Boer lands after 90 minutes and says to Opitz, "This aircraft cannot be beaten conventionally. It dictates every engagement. We can only win through mistakes, American pilot errors, mechanical failures, or overwhelming numerical advantage. We cannot count on any of these." Wolfgang Spicaya flies third, conducting extreme dive testing. He climbs to 35,000 feet and enters a vertical dive, pushing the P-47 beyond Lurch's 500 mile/hour test. The airspeed builds past 500, past 520, reaching 540 miles per hour indicated before Spicaya begins recovery at 10,000 feet. The pullout generates over 8G, his vision completely blacking out. But the P-47 survives without structural damage. He lands, and his report is 3 sentences. The P-47 can dive at speeds that exceed instrument limitations. No German fighter can follow. The structural margin is incomprehensible. Opitz flies last, conducting instrumented testing, documenting that the R-2800 produces 2,000 horsepower at sea level, maintaining power to 25,000 feet through turbocharging. The specific power, horsepower per pound, is nearly equal to the Bf-109, despite the massive weight difference. American engines are simply more powerful. American structures are heavier, but proportionally so. The result is performance parity or superiority across most domains. March 11, 1944. The 4 pilots compiled their findings into a report. 52 pages, documenting every test, every measurement, every conclusion. The summary section states the Republic P-47D Thunderbolt represents American design philosophy taken to its logical extreme. Solve performance problems through power. Solve survivability problems through structure. Accept weight penalties to achieve capability. The result is an aircraft that weighs 14,500 pounds fully loaded, twice the weight of a Bf-109, yet achieves equal or superior performance in speed, dive, climb, and range. The P-47's ability to dive safely at 500 miles per hour gives American pilots complete control over engagement parameters. German pilots cannot catch P-47s that choose to disengage. The P-47's structural strength and armor protection allow it to survive damage that would destroy German fighters instantly. Combat reports of P-47s returning to base with extensive damage are confirmed as accurate. The aircraft is designed to bring pilots home alive. German fighters are designed for optimal performance. In attritional warfare, survivability defeats performance optimization. The report is classified. Delivered to General Field Marshal Erhard Milch on March 14th. Milch reads it, forwards it to Hermann Göring with recommendations for immediate structural research to match P-47 dive capability and for accelerated jet fighter development since piston fighters cannot compete. Göring's response is predictable: anger, denial, insistence that German fighters are adequate. The report is filed. Nothing changes, but the knowledge spreads. Pilots hear that official testing confirmed their combat experience. The P-47 is superior in every domain except turning. Morale suffers. Some pilots request transfers. Most requests are denied. By mid-1944, P-47s dominate the skies over Germany. Over 15,000 are produced. They escort bombers, strafe ground targets, sweep German airspace. German pilots learn to fear them, learn to disengage when P-47s appear, learn that survival requires avoiding combat unless conditions are perfect. The captured P-47 at Reckland is destroyed in a bombing raid in July 1944. The test data survives. Scattered, some lost, some recovered by American forces after the war. The American analysts read German reports with satisfaction. The Germans confirmed P-47 performance matched specifications exactly. But they also confirmed something more important. The Americans had built a fighter that couldn't be beaten with available German aircraft. The knowledge was documented, filed, and ignored. The war continued. Pilots died. And the lesson that acknowledging uncomfortable truths is the first step to solving problems was never learned. The P-47 evaluation proved Germans could see their predicament clearly. They simply couldn't change it. The P-47 evaluation is one piece of World War II's technological puzzle where engineering decisions made years before determined who lived and who died when combat came. If you want more primary source stories like this, deep investigations into the technical battles that shaped history, subscribe now. We publish every week. Thanks for watching.